Welcome to Science That Sticks, Group 1 elements, Group 7 elements, roll the graphic. Hi, I'm Paul, welcome back to Science That Sticks. Today I'm going to talk to you about Group 1 and Group 7 elements. To my side here we have the Group 1 elements. To this side we've got the Group 7 elements. Ta-da! But let's not worry too much about how much of a superstar they are. Let's actually concentrate on describing the properties of these elements and their reactivities, and then explain them in an effort to give you everything you need to know about Group 1 and Group 7 elements. The Group 1 elements, they're metals. They are lithium, sodium, potassium, rubidium and cesium. They get more reactive as you go from the top down to the bottom. The Group 7 elements are fluorine, chlorine, bromine and iodine. I've put astatine there just so that you know it exists, but you can't really get hold of much of that because it's radioactive. It's unstable, so it doesn't exist for very long. So we're only really bothered about these four. So let's look at some of the reactivities. I've just said that this is terrifyingly more reactive as you descend the group. This is the opposite. Why is that? Well, firstly, all of these have one electron in their outer shell. And because their outer shell can hold a maximum of 8 electrons, as far as GCSE students are concerned, you will know that it either has to gain 7 or it's much easier to lose 1. So energetically, they lose 1. And those electrons can be transferred from the outer shells of here into one of these. Hence, they form 1-to-1 ratioed salts. And they will be salts with high boiling points, high melting points, because they have ionic bonds. Now, why do they get more reactive? It's not just because they've got 1 electron in their outer shell. That electron gets further and further and further away from the nucleus, and there's shielding by the electrons in inner orbitals. So therefore it becomes energetically easier for it to lose that 1 electron down at cesium than it does up at lithium. These bad boys, something different with those. First of all, they don't exist as like a metal like those. They're not in a metallic bond. They happen to be in diatomic molecules. So elementally, they are always going to be F2, Cl2, Br2, I2. That's the first point. The second point is that each of those molecules is going to be covalently bonded together so that they share that 1 electron. I talked about covalent bonds in a previous video. Now, each of those molecules is going to be bigger than an atom on its own, and because it's got a molecule, it only has weak intermolecular forces in between it. So as a result of this, as you go from fluorine down to iodine, the melting points increase, the boiling points increase, and this is because the atoms that make up the molecules get bigger, and because the molecules get bigger, those intermolecular forces get stronger, which requires more energy to overcome them. That's pretty much it. So when it comes to the Group 1 or the Group 7 elements, all you've got to think is more reactive, less reactive, 1 electron in its outer shell, needs 1 electron in its outer shell, metal bonding, covalent bonding, just has intermolecular forces, but when they react, they form an ionic bond. That's it. That's all I wrote. Until next time, ladies and gentlemen, stay cool. Goodbye.